In our plate tectonic story, we now come to the difficult question of what drives the plates. And there are three different ideas, hypotheses, about what drives the plates. In the diagram on the right here, you can see the one at the top is ridge push, and that's where new plate material is formed on oceanic ridges at a higher level than the surrounding seafloor, and the plate slides off, pushing the plate in front of it. The diagram in the middle here shows mantle drag. That's where the convecting mantle flows along in a convection current, dragging the mantle with it, the convection current model. And then the one at the bottom there is slab pull. And on the left hand side of the diagram, you can see that old cold plate sinks down into the less dense surrounding rocks, pulling the plate with it. So those are the models. We now need to ask, what does the evidence show is the best of these theories? Well, if we look at for the evidence, for ridge push, we'd expect the plates that were moving fastest would be those with the greatest length of oceanic ridge. If mantle drag were the main force driving plates, then you'd expect the plates with the largest surface area should be moving the fastest, because they would have the largest area engaging with a moving convection current. And if slab pull were the main theory, then you'd expect the plates with the largest or the greatest length of subduction zone to be moving the fastest. So what does the evidence show? Well, there is a strong correlation between the speed of plate and the length of subduction zone. So the evidence there is that slab pull is the most important force. If we look at the evidence for mantle convection, the mantle drag idea, there is no correlation there, and so it looks like that has no importance in plate tectonics. And if we look at ridge push, there's little correlation, but we think that where slab pull is not happening to a great extent, ridge push is likely to be having an effect there. So those are the ideas, and we think slab pull is the most important of those. How can we help pupils to remember the models and to remember that slab pull, we think, is the most effective of these?
We can get a group of people, and here they are, and these people here are all lined up, and they've got linked arms because this is all one plate. We've got another plate going in that direction, but we haven't shown that with people because we don't need to. And the two people here are showing the edges of the plate margins at the oceanic ridge. Now I haven't got people here to show that. What I have got instead is some Lego people, and here they are. And these can't link arms because they're Lego people, but they are all linked together like the plate here is. And here we have the other plate margin, the two people in the caps are the plate margins, and that plate would move that way. So how can we demonstrate these different mechanisms? Well, if we want to show mantle convection, the mantle drag idea, we would take a figure here, and the figure would walk along the back and would nudge the people there, but this is not actually moving things along very much because there's nothing for the mantle current to engage with, to drag along. So if we now want to demonstrate the ridge push idea, we could do what this person here is doing and go in between and push them, nudge them apart, and we could do that here, and here I am nudging them apart, and that's the ridge push idea. But if we really want to show what's going on, we need to go round to the end here, as you can see on this picture here, and take hold of the person at the end and give them a good pull, and that slab pull is the most effective way of moving the plates along.